Review number 4. In this problem they're talking about reading ease and fonts, and so they're talking about that it takes an average of 22 seconds for an adult to read 4 paragraphs of Times New Roman font. So I'm going to write my null hypothesis here. My null hypothesis is going to be that the the average time it takes to read any font is going to be 22 seconds. Versus, we're going to have to get the alternative here. The data, they're asking the data, they give us some data, and they said, does this provide convincing evidence that it takes longer than 22 seconds? So my alternative is that mu is greater than 22 seconds. Okay, so I've got my null and my alternative based on what's said in there. We have 24 adults, so n equals 24. And we have a bunch of data, which I have put into the calculator, into my L1. I think I have all the digits in there correctly. I hope so. You guys will tell me if I don't, I'm sure. So then they give these 24 adults a different font to read, and they test them, see how long it takes to read the same length of text. And it's in an ornate font called Gigi or Gigi or something like that. Anyhow, so it wants us to know is there a significant difference between what they expect and what they actually observed. So this is a test. This is going to be a t-test. Now I have to start with conditions. This is going to be the whole thing all in one deal. So is it an SRS? I didn't read this to you. I got to look here and let's see. They does say researchers asked a random sample of 24 adults, so this is given. If I were doing this for the AP, I'd say random sample. If it were me, I'd do that just because then you're quoting where you got that out of the diction there. Is it reasonable to think that there's more than, let's see, all literate adults do you think 10% of all literate adults is greater than 24? Yeah, I'm not even sure you need to put reasonable to assume there. That's just sort of like, really? But if you want RTA, reasonable to assume, yeah, I don't think an assumption is even necessary there, to be honest. And then is it normal? Well, that's where we have to get the graph out. So I'm going to graph the data and see. I'm looking to make sure there's no crazy skews and no crazy outliers. No outliers at all. So I'm going to use my histogram first. Have a look at that. That looks pretty normalish to me. I mean, it doesn't have to be perfect. Just for the fun of it, I don't really think I need to, but I'm going to have a look at the box and whisker. And again, no outliers, no crazy skews. So I think we are good to go. If I were doing this for the AP exam, I would actually make some quick sketches of those, just what you see on the screen. But for us here, for this, I'm going to say no massive skew, or outliers are noted in the graph. Do you have to say that exactly like I did? No. Just tell me that you didn't see it in the graph. So our conditions are met. Now I can do the calculation. Now it's going to be a t-test, so my calculation, if I were writing this out, it's going to be x bar minus mu sub naught, which is going to be the 22, over sx divided by the square root of n, which I know that's 24, but I'm missing the other bits. So I can do one var stats and get this value and that value and plug it in if I wish and then go to the table. I could do that, but I'm going to use the t-test. I'm going to use this guy right here. So I'm going to go to stat, tests, t-test. In this case, I've got the data. It's in the calculator. I'm going to let it do the work. I still have to tell it what the null hypothesis is, and that's going to be 22. 22 seconds in this case. My list is in L1. Frequency is 1. This really we almost never change. There was a couple times there in probability where we changed it, but and this is a greater than 22 seconds. So we're going to calculate this. So I did a t-test with my null hypothesis. P. Now be careful with this p value. Look at this. This is 5.09, but it's not because it's in scientific notation. So if I were going to write this out, I'd go 0.000051 maybe. So it's really small, which means it's definitely significant. Since I didn't get X bar anywhere else, I'm going to write that in. 26.51 SX 4.71 and N equals 24. I kind of already had that, but I'll put it in there again just for the fun of it. It's because I like to write, I like to waste pencils. So here's the deal. This p-value is less than any reasonable alpha. It just doesn't matter what you set alpha at. It's going to be less than. So the p-value is less than any reasonable alpha. And so I'm going to phrase this one a little bit better this time. I'm going to say we have significant evidence. To reject the null. We're in the tail. We're going to reject the null. And conclude that the font, that the fancy font causes readers to take longer, or increases reading time. And that's it for 4. That's pretty much beginning to end on a problem. If you can do that, you're in good shape.